Good morning, this is Dr. Turner for Fundamental Mathematics. Today we're going to be covering 10.4. 10.4 is looking at solving equations where we have variables on both sides. In 10.2 and 10.3, we looked at 1- and 2-step equations. Potentially for these are essentially 3-step equations. So it's going to look sort of similar to what we've just done in the last two sections with one extra step. Let's go ahead and get started. So for something like the 10.4, we're going to have something like 3x plus 5 equals x minus 11. Okay. So here we have variables on both sides. So it's not as simple as just following the last two steps, which were to isolate the variable term and then isolate the variable, because we have variables on both sides of the equation. So what we're going to want to do here, and you can do it a little bit differently, but what we're going to do is first, gather the variable on one side of the equation, and then we're going to isolate the variable term and then isolate the variable. So we have 3 steps here instead of 2. So step 1, we are going to gather the variable on one side. That means I want all of the x's either on the left or the right. It doesn't matter which is which. Usually we're used to thinking of the variable as being on the left, which is totally fine. So to do that, then I need to move this x to the left by subtracting an x on both sides. Remember, what you do to one side of the equation, you have to do to both. That gives me 2x plus 5 equals negative 11. Now this is just like 10.3. We're going to first get the variable term by itself. So I'll subtract 5 on both sides, being careful with your positives and negatives. That gives me 2x equals negative 16. And now it's like 10.2. Get the variable by itself, divide by 2 on both sides, which gives me an answer of x equals negative 8. So like I said, it's essentially a 3-step equation. 5x minus 7 equals, let's say 2x plus 14. Gather the variables on one side, so I'll subtract 2x on both sides. It gives me 3x minus 7 equals 14. Next, isolate the variable term, so I'll add 7 on both sides, which gives me 3x equals 21. And then isolate the variable on both sides. Divide by 3, gives you x equals 7. Now for all these examples, I'm trying to stick to cases where you have an integer as an answer. You can have a decimal, you can have a fraction. I'm just trying to make sure you guys understand the process here, but just be aware of that. Just because you get a decimal or a fraction or a positive or negative doesn't mean your answer is wrong necessarily. Okay. Let's try another one. 9x plus 17 equals 4x minus 20, minus 13. So first gather the variables on one side. I'll subtract 4x. And then isolate the variable term. I would subtract 17 on both sides. And then isolate the variable, divide by 5. The answer is negative 6. And of course, just like in 10.2, 10.3, if you want to check your answer, you can go plug that in and verify that both sides are equal. Let's do one more. Negative 3x plus 7 equals negative 5x minus 1. So first I'm going to gather all my variables on one side. So I would add 5x to both sides. Then isolate the variable term, subtract 7 on both sides. And last, isolate the variable, divide by 2 to give x equals negative 4. If you guys have any questions, please reach out during office hours. Otherwise, have a good day, and I will talk to you soon. Bye.